interactive. So anytime that I'm talking about instrumentation, monitoring principles, any slide you see, anything in the demo, please send in a question as soon as you have one. We like this to be conversational, fun, interactive. So I'll do questions throughout the whole presentation. Don't wait till the end to send them in, and we'll get started. So today, we've got a little bit of slides and then hopefully a whole lot of demo. I'll be in a ECS environment, a EC2 environment with Kubernetes running, and then I'm actually going to instrument a live Docker environment running on EC2. So you can kind of see different ways to get metrics and how easy it is to get started right out of the box. So the reason why a lot of us are here is monitoring containers is different. And deploying tools like ECS and Kubernetes and Mesos to split up your application into services and using containers to do that really breaks the legacy monitoring and analytics tools that you're using. And Sysdig is the first and only solution that can natively monitor any infrastructure and app, including container-based ones. So what we mean by this is we'll be able to kind of you really care about, if you're running Mesos, to look at information by how a certain task is performing, or if you're on ECS, how a certain service, or Kubernetes and a deployment. You don't really care about your individual containers. You care about the services and how they're running and the performance that your end user is getting. So before we kind of get into the service view, let's go all the way back to the containers and talk about why monitoring containers is different. So I remember the first time I did something on my laptop in a container and then pushed it to EC2 and it's running the same way, and it's awesome. I can isolate my app into different processes, but that isolation also makes it really hard to see what's running inside each container. And you don't really want to go Docker exec in, or if you're pulling the Docker stats API, I'll get the CPU, memory, and network for the container, but I had no idea what was actually running inside each container. One way to do that is to put an agent inside each container, but if you're using something like ECS, Kubernetes, Mesos, you have containers that are running 10 seconds or getting scheduled across a huge distributed environment. And having an agent inside each container isn't something that's going to scale, and making sense of all that data is going to be really hard. And then last, like I talked about before, yesterday's monitoring tools don't understand today's microservices architectures. So if you want to know how your Cassandra service is performing when it's distributed across multiple availability zones, EC2 instances, how do you make sense of all that data and aggregate it in a single way? So I'll take a step back and talk a little bit about our instrumentation. And what we've done with Sysdig is taken a unique kernel level approach where we run our agent as a privileged container on each host in your cluster. And that's going to allow us to see inside all your containers, pull application metrics, host metrics, container-based metrics, and then network metrics as well, without you having to do any configuration on your end. And the way that we've done this is through a kernel module. This kernel module is fully open source. It's part of our sysdig.org open source project, which has a couple 100,000 users. It's part of the Sysdig Cloud product, which you can deploy both as a hosted SaaS service or host it yourself on-prem. And then it's also a part of our new security open source project as well. That's called Sysdig Falco. And I'll chat that link into you guys right now. This kernel module is used there for deep system visibility as well. And this kernel module will allow us to trace every single system call that's happening on the host, and then auto-discover the processes that are running, the applications, network metrics, all that kind of stuff. And what we'll do with our agent is collect and analyze all those syscalls, tag them with all your environment metadata, so the EC2 instance, your ECS service name, the Mesos all the Mesos information, pull the API of all the masters of the different orchestration tools you can use, and then take that data, aggregate it, and send it to our backend, where you can build all the visualizations on top of it. So what does that instrumentation give us? There's three main things that you really want in a microservice-based monitoring tool. And the first would be service-oriented performance management. So that's getting a logical view of how your services are performing, interacting with each other, latencies, app metrics, all that kind of stuff. The second would be application intelligent monitoring and alerting. So having alerts that scale as soon as new services are brought online, pre-built dashboards for services as soon as they start, and then just out-of-the-box support for your StatsD, your JVM, your JMX metrics, and a host of other applications. And then my favorite part here is actually trace-driven troubleshooting. And because of the ephemeral nature of containers, a lot of the time, the best way for me to stop a problem is to just kill a container. But if you keep on doing that, you'll have issues that manifest. And so when you kill a container, you're really going to want a whole lot of data about what's actually happening. And so it's really important to get basically all the syscalls and every event that's happened when an alert fires or when you hit some issue. So a lot of your applications are probably looking like this. I know that Roberto had said he was running some Mesos and Marathon, and so you probably have multiple frameworks and multiple tasks on shared resources. And so how do you make sense of all these different services that are running on shared nodes? And what we'll help you do is apply all your logical metadata, so then you can look at your applications in a view like this. So no longer are they scattered across multiple hosts. It's one logical service with the network impact, application metrics, all that kind of stuff. We'll also integrate, like I said before, with all your orchestration metadata. So the pulling the Kubernetes master API, Mesos API, Mesosphere, all that kind of stuff. And if I were actually back at our San Francisco office right now, I could flip my screen around and show you the Mesosphere office. So we're close partners with all these guys, close partners with Amazon, and really rely on pulling their metadata to give our users kind of a better experience with those services. So before I get any further, does anyone in the audience have any questions about the instrumentation or anything on that end? So it looks like I got a question. Can you go a little bit further into the kernel module? Yeah, so our kernel module is built on a facility called DKMS. Basically, what that does is looks at the existing version of your kernel, builds our module on top of it, doesn't require a kernel restart, and basically all the syscalls are put into a ring buffer. From there, they're put in and the processing is done at user space, so no impact, won't add any latency or anything like that. I'll chat you in some of the links to the kernel module on GitHub and stuff like that if you're interested, Ben. Cool. So the next thing with monitoring and alerting, with your applications, having auto discovery is really important. So if you're bringing a Cassandra service, a MySQL service, Zookeeper, especially with Mesos, automatically discovering that those are running and starting pulling metrics from it. So you don't need to do any code instrumentation. Your monitoring really should scale as fast as your applications do. And then once those metrics are being collected, having pre-built templates so you can automatically have dashboards and different views to look into your infrastructure and the services that you're running on them. Also, when I first started at Sysdig about a year ago, the first thing that I thought was just so crazy is the statsd and JMX integration. So if you have statsd running or JMX, our agent will actually act as a statsd server. So you can pipe your metrics to dev null, you can pipe your metrics to localhost, or just keep them to wherever you're sending them before. And the agent will act as a statsd server, automatically pick them up, and then send them to the cloud backend with all the metadata that you already applied. And then last is anomaly detection. So taking all the data, establishing envelopes around certain metrics, and then spotting anomalies against that, and then applying any of those alerts to your application as it scales. So if it's brought up in a new AZ, putting all that historical data and applying those policies against your new services. So this is another area where I'm going to pause for a second. Can anyone in the audience, if you're using any of these applications, can you please chat them in, and I'll do my best to kind of cover them in Sysdig while we're going into the live demo environment. Okay, so we've got one person running Node, some others with MySQL and PHP, Docker, AWS, Node.js, awesome. Roberto, are you using any of the AWS services like ELB or RDS or anything like that? Yes, okay, cool. Nginx, Zookeeper, Node, awesome. So it looks like we've got a bunch of these logos covered on here. I kind of call this a logo soup slide because each person kind of has different things that they're using that make up their application. And so it's easy to just throw it up and have people chat in. So I'll actually, if we have some time at the end, log into a different environment and show you guys how we can actually see some of the data that ELB or RDS doesn't even natively expose through CloudWatch and those kind of tools. So let's finish actually with kind of my favorite feature in here, and this is trace-driven troubleshooting. So this is the ability to kind of move past a spike in your dashboard and get all the syscalls for an event when an alert happened, or if you're just troubleshooting your environment and want to get just basically a TCP dump of your kernel and see everything that's going on. And so this is kind of the ability to move back in time, get all the data from containers that you previously destroyed, and troubleshoot it on your local machine without even having to get into your prod environment or anything like that. So I told you the slides would be quick. You're really here to see a product and get into the command line and do all that kind of stuff. So let me switch over. I'm going to actually start off with the ECS environment, go through that really quickly, and then move over into a live instrumentation of a system. All right. Can everyone see my screen okay? Awesome, cool. Thanks, David. So one of the first things that will kind of help you build is this is actually a default dashboard. If you're running AWS, all you would have to do is click New, and then move on over to select ECS Overview. And what we'll do here is be able to give you an overview of your entire ECS cluster and pull the metrics and the metadata that are related to that cluster. So showing the request counts by the different services that you have running. So your Redis service, your Java app, the container counts per service, and then actually move in a little bit further and show you some host-based information as well as your infrastructure information or your application information. So the total containers running per host, your capacity utilization, and then move on more into the service-based stuff. So your top resources, your slowest resources, how different containers or different container images are consuming file system percentage, memory percentage, CPU, all that kind of stuff. But what makes this really powerful is the flexibility in the grouping and all the metadata that is exposed when you use something like ECS or Docker or Mesos or anything like that. So a typical view you would get of your infrastructure, and the one that most people probably see right now, is you have multiple hosts running with multiple containers per host. But like we've talked about before, is you really care about those services. And so using that metadata, I can apply a view of, okay, what's my ECS cluster? What services are running on that cluster? And then how many containers will make up that service? So I can click on this Java application here and then get aggregate metrics and information about how that service is running as a whole. So heap usage for that entire application, and then drill into any container and get the individual data for that container as well. So you can see things spiking, moving off, all that kind of stuff. So while it's nice to show kind of like a pre-canned environment, I think it's much more powerful to show how easy it is to instrument a system and the auto discovery that you can get. So I'm gonna actually move over now into a personal environment that I have. As you can see, this environment's pretty sad right now. No data is going into it. I'm even on a trial. So what I can do now is actually, let's go and check out what's running on that environment. So right now I'm just on a small EC2 host. And if I do a Docker PS, I'll be able to see I've got a HA proxy container, a WordPress container, a MySQL container, just a simple web app running here. And what we'll want to do now is just actually instrument that system with Sysdig. And so if I go to my settings here and the agent installation, it's just a simple Docker run command. So if you are using Mesos, or if you're using Kubernetes or ECS like that, you can add this kind of you just edit the daemon set or something in your Mesos frameworks, and then that will put the container on every host in your cluster, automatically connected to the API, and start applying and pulling metrics for across your full cluster. So now let's go over to my terminal. I'm actually gonna take it out of running in daemon mode so we can see the output of what happens here. So if I hit enter, it's going to start that container. It's loading the Sysdig Cloud probe, which is the kernel module. You can see the DKMS auto install. So we're looking at the version of the kernel, doing the build, and then you'll see different checks running here. So some app checks. Looks like that if you scroll up, you can see it's pinging the Mesos API. And then now it's connecting to the cloud backend and sending data. So if I go over to my Explore tab, we see my host. So my T2, really small micro host on ECS. And then you can see I've got my HA proxy, the new Sysdig agent, a MySQL container, WordPress, all those different services that we saw before. And let's actually drill in first into this MySQL container and look at what's going on here. So we can see CPU, memory, network, the kind of basic things that you would expect. But since it's MySQL, let's actually look at what the application is doing as well. And if I click on this MySQL Postgres view, we're going to automatically start pulling the metrics like number of requests, number of errors, average request time, top queries, top tables, slowest queries. So what we're actually doing here is decoding every single TCP connection coming in and out of the database, taking out the individual SQL string, and getting that data for you as an admin or any of your developers or something like that. I was at a conference earlier this week as well, kind of demoing this for some people. And one guy was like, I've been asking my DBAs to do this for a month. Like, this is crazy. So it's something that will bring you huge value as soon as you install the agent. Okay, Roberto, does this work for RDS? Yes, same exact thing. I'll show you that if we have a little bit of time at the end with the specific ELB and RDS stuff. But basically, we'll be able to give you this exact same type of information for RDS. So the top tables, top queries, slowest tables, all that kind of stuff without you needing to do anything. And the cool thing there is that's data that Amazon doesn't even expose through CloudWatch. So let's actually move out of my small T2 micro instance and get into a pretty robust environment with Kubernetes running on EC2. Before I switch over to there, does anybody have any questions of what I've covered so far? All right, looks like we're good. The other thing that I forgot to mention at the beginning, we do a contest usually during these webinars. So if you ask a question and you kind of stump the presenter, we'll send you a t-shirt. So keep the questions coming. We don't get stumped often, but when we do, we're happy about it. And we'll send you guys a t-shirt. So keep the questions coming. So what we're looking at now is a physical map of my 4-node Kubernetes infrastructure. And what we can see here is just the 4 different EC2 instances. And what I can do now is drill down into each individual instance and see all the containers that are running on that instance, and drill down a step further to actually see the process that's running inside of each container and all the network connections between them. So if you're trying to visualize this with any other type of tool, you might be able to see the containers that are running on each host, but without instrumenting any containers, there's no other way that you'd be able to see all the way down to the process level of what's running inside. So seeing that Nginx is running inside this Java app and that it's using 0.33% of the CPU host. But as you can kind of tell in an orchestrated environment with ECS or Kubernetes or Mesos or anything like that, this map is just an absolute nightmare to look at from a physical perspective because I've got a Redis service, my Kube Sky DNS, my health check that's running, the Kube proxy. And so what you really care about here are those logical services. And this view that we're looking at right now has basically my 4 Kubernetes namespaces. So you can think of this as your different ECS clusters or your different Mesos frameworks. And I can drill down into this prod namespace. And now I'm just getting a view of how my logical services are interacting with each other. So I've got a Java app that's talking to a Mongo and a Redis service. And then I've got a client here that's talking to WordPress, that's talking to MySQL. And then I've got a Cassandra service that's not connected to anything. This is something new that's in the demo environment for me, so it's something that I might want to look into later. One of the funnier examples I've seen with a customer during support is he was like, yeah, I logged in and Redis was talking to Mongo. And it's like, why is that even happening in my world? Like, that's crazy. But from here, you can actually drill into any service and then see the components that service is made up of. So you've got a Java load balancer here, and then 3 different Kubernetes pods. And so you can drill it back into any pod, all the way down, see the container running inside, and the processes running inside those containers. So it's a logical view where you can easily see your applications, how they're interacting with each other. And you can dynamically change this to get a different overview of how your system is running. So right now we're looking at the latency with net request time, but you can change that to net bytes sent. Maybe you care about connection count, things like that. So it looks like we had a couple questions come in. Do we support .NET Core? Right now, we do not support .NET. If you are exporting metrics via StatsD with .NET, we could pick it up. But as far as if you're, I'm not sure where you're running the .NET stuff. If it's on Windows, we currently don't have a Windows agent. It's in the roadmap. We should be having it within the next year. But right now, it's more of a it's just a Linux. Okay, .NET Core on Linux. Then you might be able to send some of that in with StatsD, but it's not one of the default app checks. If you one of the other ways that you can send any metrics into Sysdig Cloud is through your own app check. It's a small Python script that you would just add to the agent config file, and then from there, if you have any custom application or are exporting metrics in your own format, you'll be able to just add that to the agent. The agent will recognize that process, trace the syscalls for that process, and then export those metrics to our cloud backend. So now that we've kind of covered the mapping on the dashboard, I can just go through a couple of the other main dashboards. Right now we're looking at the service performance for our web app. So you can see request counts, error counts, top endpoints, and then you can actually even put maps in a dashboard that you set up, time series graphs, status codes, request types, all that kind of stuff. And any of these panels you can dynamically change the size of. If you want to have this up on a NOC somewhere in your environment, you can edit any panel, change the thresholds there so it brings stuff to your attention quickly. So like HTTP error counts, all that kind of stuff. So next I'm going to actually move back over to the Explore tab and see what's going on there. So what we had talked about before is the kind of the host-based view versus the service-based view. And let's move back over to our services with all the different data that Kubernetes or ECS will expose. And so I can drill down into these prod services, and let's look at WordPress this time. Actually, let's look at this Java application. Is anyone in the audience running a Java app right now? Cool. Okay, so one or two. All right. So in this Java application, we can get a logical view of how that service is running as a whole. So if I put this default service overview view here, you'll be able to see all the container counts across that service, request count, request time, net connections in, response time versus the resource usage. But the really cool thing here is I can expand this logical grouping that I have, and anywhere where I change the scope in the table, it's going to default change the dashboard that I have below and let me drill down into whatever grouping I had selected there. So I went from a service to an individual Kubernetes pod, and I can see how that pod is performing, the containers that are running in there, the request times, the connections in, all that kind of information. So it's really nice to, if you build your own custom views or custom dashboards, being able to quickly go through your environment, compare how different tasks are running, or if you see that maybe like this, the file system root usage for this Java client here was higher, so I might want to drill in further to that. I could even look at maybe my connections table here. This might be kind of small because it's just a Java app. Yeah, so I can see all the connections that that pod has to the remote endpoint, the service, and then look at different network information for that as well. So it's a really easy way to dynamically kind of move through your environment and not have to switch between different services. Now, the other thing that you can do is use any dashboard that you had created as well. So if I go over to my dashboards and then scroll down to this JVM CMS, we'll automatically see the stuff like heap usage by process, all my garbage collection information, without you needing to instrument any of your JVM or something like that. The other thing that users always care about is alerting. So there's pre-built alerting in here as well. And what you can do is anywhere that you're drilling into your environment, if I set an alert there, it's going to automatically set the scope to what I had been exploring before. So this is for my Kubernetes namespaces production. The deployment is my Java app. And if we were running ECS in here, you could pick a service name, a cluster name, Mesos. Mesos isn't running, obviously, so that's where you could set a task or something like that. And probably I don't care about an individual pod. I care about that service, so I can just delete this. And then from here, there's 3 different types of alerts that you could create. So a manual alert, a baseline, a host comparison. A baseline will look at your historical averages and then spot the anomalies against that. And then the host comparison, I've seen a lot of people use that if you have load balancers or things like that to make sure individual hosts are staying within a certain deviation of each other. From here, we also have Boolean Logic, so multi-condition alerting. This is really nice to reduce the pager fatigue and make sure you're just not spamming yourself. So you can have, like I used to work in the database space, so I didn't really care if memory was high unless my transactions per second had fallen. And so you can easily kind of have multi-conditions and run them against each other. From here, you can also segment the alerts, so by a different namespace, anything like that. Give them a name, a description, set the severity, and configure different notification channels. So is anyone in the audience using Slack right now? And then we also will integrate with PagerDuty, VictorOps, Amazon SNS, OpsGenie, email. But there's some pretty cool stuff that we built with Slack if anyone in the audience is using it. Awesome. Roberto, you've been great so far. So David, also Slack. We built a Slack bot that can actually serve as an event proxy into Sysdig. So I'll chat that in to you guys now. The really cool thing here is you can pipe in anything that you send into Slack into Sysdig Cloud. So we have some people sending in business events. We have some people sending in deployments, bugs, alerts from an elk stack. Really, you name it. If you're sending it into Slack, you can send it into Sysdig Cloud as a custom event. And the last thing that you can do with this alert here is trigger a Cystic Capture. And so what this will do is give me that dump of all the syscalls that happened when that alert went off, and then let me take that down to my local machine, troubleshoot it, do all that kind of stuff there. I'll actually pull down a capture later and then show you a little bit about how you can troubleshoot your capture with the Sysdig open source tool. So now that we've shown how to create an alert, let's actually go back and explore an alert that's happened before. So I'm gonna stop my share for a second so I can log it into my Slack environment and get an alert that's fired up. So while I'm doing this, now's a great time to also send in any questions if you have them. All right, so now you can hopefully see the Slack channel. And so this is a channel where alerts have been routed, and you can see if an alert has been resolved, alerts that have been sent, the metric that the alert was set on, the different scopes, severity, all that kind of stuff. So if I hit view notification here, this is going to drop me back in time to when that alert fired and let me see what was happening in that environment. So if I scroll down here, I can see the metric going across the net connections to my MySQL database, this green line, which is the threshold, and when the alert actually fired. So if I hit explore here, this will take me back in time, so to 3:16 to 4:16 p.m. And I can see that it's happened to my MySQL environment in my dev namespace. So right away, I'm kind of curious to make sure that this is only in my dev environment. So what I can just easily do here is change this grouping. And if I click back on MySQL again, I can segment based on the different environments or hosts that it's running on. So if I type in namespace here, I'll get a nice view of my two different environments. So prod looks like it's running fine, and this alert is really limited to my dev environment. So the other thing we'll do is also ingest all custom events from Docker or Kubernetes as well. So a container getting restarted, and that'll apply to ECS. A container out of memory, pods being killed, all that kind of stuff. And so if I tooltip over this custom event, you can see that there was a WordPress deployment, and this event was routed in through our API. Pods were deleted, some scaling. So it looks like that deployment killed the old service, started some new ones. So a custom event, replica set scaling, containers killed, the source was cube. And if I go over this event here, I'll see this is actually when the event fired. And then if I look over at the graph, it looks like performance is normal. So what happened here? So there's some more scaling, pods were deleted. If I scroll all the way to the bottom, we'll be able to see that there's a custom event that was routed in, which is rollback, Jenkins rollback. So at first build 89 was pushed, something went wrong, and then the dev team rolled it back. This event correlation is really easy. It's all searchable as well. So there's some people that I see that have just line after line after line, and you can apply different filters here. So if I search based on deploy, then these are only down to 5 events with the deployments, all that kind of stuff. Oh, okay. Thanks for the notification about audio. Sorry if it cut out for a second. So it's, yeah, fully searchable, and you can choose to only show custom events, alerts, do based on the severity, the state, if it's been resolved or not. So if you have a dev environment with bugs that you're pushing in, things like that, it's a really easy way to toggle on and off and get pretty deep event correlation. So the other way to really troubleshoot your environment is with those Cystic Captures. And if I open up the Sysdig tab here, you'll see all the different captures that have been taken from alerts or manually. The way to manually take a capture is if you're just in your environment and you see something that you want to drill down into and get all the data for. If something's spiking, or maybe if your orchestration is having some networking issues, something like that, you just hit the shovel button and then can name the capture, say how long you want to take it. Probably 10 to 15 seconds is definitely enough, because it'll capture every syscall, and you'll have a ton of data to go through. So if I go into the Sysdig tab, I'll be able to see all those files. You can look at them in here as well with a tree map. So these sometimes take a little bit to load based on how many processes were going on at that time. So I can see all the different process names. Right now they're filtered by CPU usage, drill into any process, see the PID. So it looks like 1112 was the main one. Drill into that, and then you'll actually get all the process arguments that were happening during that time when that alert went off. The easier way to go through these is with our open source tool. When I open this up, has anyone in the audience used or seen the Sysdig open source tool before? Okay, cool. That's awesome, David, that you've used this or seen the CLI before. So what you can do is use csysdig or Sysdig to open up a capture file and read from it. I'm going to use csysdig because it's a Cursus UI, like easier to filter between different things. It's really similar to HTOP if you've used it before. And so if I hit enter, right now I'm looking at all the processes that were running on that host at that point in time. So if I hit function F2, it's going to apply a whole bunch of different filters that I can use. So I can look at how a specific Mesos task is performing, CPU, virtual memory, non-swapped memory, the ID, task name, all that kind of stuff. So just to keep it more general right now, let's look at what containers we're running on that host. So I can see I've got my Redis container and our Sysdig agent. And then I can actually go inside that Redis container and isolate that single process that was running at that point in time when the alert went off. And if I hit function F6, this will do a dig, and I'll be able to see every single syscall that happened when that alert went off. So you can see there's basically a heartbeat happening. There's an open, it read from a file, it closed that file. And you can move through there, filter on this, do a whole bunch of different things. You can also inspect I/O activity. This is also really, really useful at the networking level. So you can kind of get the payload, and you'd be able to see, so with this Redis process, I can see 26 bytes were read from this host over port 36744, what was actually read, the reads, the writes, all that kind of stuff. You can do the same thing with the network traffic, so see if it's a GET or a POST, all really deep information. So that's about it for this environment. Because we had some questions about ELB and RDS, let me log out of here really quickly and show you guys some of that. While I'm doing that, any questions that you guys have, we're available for the next like 5 to 10 minutes. So please send them in. Or if there's anything else in the UI that I didn't get you want to see more of, please let me know and I'll show that to you. All right, so we'd gotten some, looks like a question's coming in. Okay, so we got a how does Sysdig work with Datadog? So you would really, Datadog and Sysdig are very similar products, so you wouldn't really use them side to side. It's basically would be a replacement for your Datadog monitoring. And the main real difference is with Datadog, you'd have to install all these different plugins, do all the app checks manually. We'll auto-discover all of those. And then also, if you're running containers, the ability to see inside, use all that metadata is something that Datadog won't provide for you. And that's kind of the real big difference between Sysdig and Datadog. It's really not a container-aware solution. So if you have more questions about that, David, we can definitely connect offline. Some members of our team can cover that further with you. So what we're looking at now is a topology view of an application that I have running on AWS. And since some of the people had said that they're running ELB, what we can actually do is drill into this ELB service. And it's great because we obviously don't have the Sysdig agent installed on any of your ELB nodes because that's a service managed by Amazon. But what we can do here is drill into that service and actually see how many hosts ELB is using to balance your load and all the connections that are coming in and out of that ELB service. And then from there, actually look at the latency of how of the connection going into ELB, the connection going out, and kind of get a nice view of how that's running. We use ELB a lot internally, and found an awesome use case using Sysdig to find a bug in ELB, worked with the Amazon ELB service to troubleshoot the issue and kind of fix that with them. So that used both the Sysdig Cloud product and the open source tool. So I'll chat that link into you guys. It's a really good read, even if you're not using ELB. It's went viral on Reddit and Hacker News, so the community really liked that one. There are also some questions about RDS. So if I click on this RDS dashboard, you can see the network impact of RDS, the top tables, slowest tables, top queries, all that kind of stuff that you would expect from your MySQL service or your Postgres service or any other SQL database, but then get that from RDS as well. Yeah, so that's about it. Really thanks everyone for joining, and I'll be around for the next couple minutes if you guys have questions. So David asked about Elasticache. Yeah, so you'll be able to pull in this Elasticache view. I actually don't have it running in this environment, but you'd be able to see region, CPU usage, memory, swap usage. I think we also have some Elasticache and Memcache views below as well. So let me click to overview. Roberto, great question. So Roberto's question was, we deploy multiple times a day. Is there a way to compare two releases easily and raise alerts when certain thresholds are exceeded? What you can actually do with the time nav here is there's a compare to, and so you can use that with time, basically with the time nav. If I did this, you'll be able to see, let me drill down more. Kind of changes in network impact, file system, disk usage, all that kind of stuff. With alerting based on events, that's something that we're going to add pretty closely. We're changing some of the alerting logic. And so basically the deployment would be an event, and then you could compare against that. So that's coming sometime in the next month or two. Awesome. Well, thanks everyone for joining, and have a good rest of your day and a good weekend. Thanks, Roberto.